Hello, today we are going to deal the topic resolution of forces from engineering mechanics. So first, what is resolution? Resolution is a method of resolving the forces which is acting on a body in two perpendicular directions. Two perpendicular directions means x and y directions. Okay, so we are going to consider the algebraic sum of all the forces in two perpendicular directions, that is x and y direction. That's like this. If you consider a quadrant, we know this is x and this is y. Okay, so we are going to resolve all the forces along this x and y direction. So before going into the resolution, first we need to consider some points. We need to remember some points. That is, when we are considering the x components, or we represent it as sigma fx, that means sum of all the horizontal components of forces. So when we are considering the fx components, we will take positive value. Okay, we will take positive value if the component is along the x direction, positive direction, or in the right direction, and consider as negative value when it is opposite to the x direction, or it is to the left or in the negative x direction. Okay, all the horizontal component. Similarly, we will take positive sign for force along the y direction. Okay, that is when we are resolving and we are considering the vertical components. If it is along the y direction, we will consider it as positive, and if it is along the downward or opposite to the y direction, we will take it as negative. Okay, so simply the forces which are to the right direction, we will take it as positive, to the left negative, upward positive, and downward negative. Okay, so first you should remember that sign. Then second one is that there should be an angle. We know a force, then the angle of the force. Okay, there should be an angle of the force which must lie between the line of action of force and any one side of the coordinate. Okay, this is the force and there should be an angle, and that angle must lie between this line of action of force and any side of the coordinate. Okay, so we should know one angle, either this angle or either the force, the line of action of force along line of action of force with the x coordinate, or line of action of force with the y coordinate, y axis. Okay, then next the important one is that if we are resolving the force along the angle side, that is, we know if we consider this theta angle and this is angle side of the force, so we are resolving the force along the angle side, then we use the function cosine function, and we are considering or resolving the force away from the angle side, it is sine. We use sine function. Okay, so here is theta is near to the x-axis, so the x component will be cosine and y component is sine. Okay, and if we know, if it is like this and we know this angle, then this is the angle side component, and this will be cos and this will be sine component. Okay, it's clear. So these points you should remember. Sine, first of all, sine, then there should be an angle. Then third one, the component along the angle side is cosine function, and away from the angle side is sine function. Then how to find out the resultant of forces? The resultant of forces is equal to root of sigma fx square plus sigma fy square, sum of horizontal component square plus sum of vertical component square, and also the direction of this resultant. The direction of this resultant is equal to sigma fy divided by sigma fx. These two formulas you should remember. Okay, then we'll go into an example. Consider two forces, 30 Newton and 54 Newton. The angle between the axes also given. We need to resolve these forces and find the resultant and angle of the resultant force. So first we are going to consider the 30 Newton. So 30 Newton is going like this, and we know it makes with the angle. So it makes angle 15 degree with x-axis, and this is the y-axis. So we need to resolve this 30 along the x and y component. Okay, so here the x component is near to the angle, so this component is cos component, that is 30 cos 15 degree, and here the y component is away from the angle, so it is 30 sine 15. Okay, So next force is 15.4 Newton. Here also we know the angle which it makes with the x-axis, that is 40 degree. Okay, here also the x component is near to the angle, so this will be 54 cos 40, and y component is away from the angle, so it is 54 sin 40. Okay, so we'll solve the components. So the direction of the axis will be depend on the direction of force. Okay, so we need to find which quadrant the force is lying. According to that, we need to consider the x direction and y direction. So now we are going to find out the Fx. Fx is the sum of horizontal components of all forces. So here two forces, 30 and 54. So for 30 Newton, the x component is 30 cos 15 degree, plus here 54 Newton is also in the right direction, that is in the positive x direction, so it is also positive 54 cos 4. Okay, similarly sigma Fy. Sigma Fy is equal to, for 30 Newton it is 30 sin 15, it is along y direction, positive direction, so it is positive. Here in 54 Newton, how is the direction? The 54 sin 40, it is in the downward direction or along the negative y direction, so it is negative 54 sin 40. You should be careful about the direction and sign. Okay, so sigma Fx is equal to 70.34 and sigma Fy is minus 26.9. Okay, so we got sigma Fx and sigma Fy. Now we need to find out the resultant. R is equal to root of sigma Fx square plus sigma Fy square, which is equal to root of 70.34 square plus minus 26.95 whole square, and which is equal to 75.32 Newton. So the resultant of 30 Newton and 54 Newton is 75.32 Newton. So we got the resultant. Now we are going to find out the angle which the resultant makes with the axis. Okay, so if we consider, we got sigma Fx and sigma Fy. So we are considering like this. This is sigma Fx and this is sigma Fy. Here we got sigma Fx as positive value, so I am considering this positive x direction, and sigma Fy as negative value, that is minus 26.95, right? So I am considering this as this direction, negative y direction. So the resultant is lying in the fourth quadrant. So we need to find out the direction of this resultant. For that we are using the equation tan theta is equal to sigma Fy by sigma Fx, which is equal to sigma Fy, we got it as minus 26.95 divided by 70.34, which is equal to minus 20.96 degree. That is this value, that is this is 20.96 degree minus 20, that is it is in the clockwise direction, clockwise with the positive x-axis. This is clockwise, or we can written it as 339 degree anti-clockwise. Anti-clockwise means it is making with the like this, with this positive x-axis. Okay, this is 20, or either way we can represent the direction. All right, thank you.